Aim. Water is unusual because it exists in all three states of matter: solid, liquid, and gas. The next experiment shows that water vapor is always in the air, even when you cannot see it.
Requirements: large glass jar, ice cubes, water, towel. Procedure: fill the jar nearly to the top with ice. Add a little water to the jar. The water level should be about an inch from the bottom. Fasten the lid tightly on the jar. Dry the outside of the jar with the towel. Place the jar in a warm spot that is not in direct sunlight. Wait 15 minutes. Conclusion:
Droplets of water, known as condensation, form on the outside of the jar. Condensation occurs when warm, moist air meets something cold. As the warm air cools, the molecules in the water vapor slow down and move closer together, changing the water that is in the air from a gas to liquid. Aim. Do you think you could bend something without even touching it? Try this experiment with refraction.
Requirements: glass, water, pencil. Procedure: fill the glass with water, leaving an inch of space at the top. Place the pencil inside the glass and lean it against the side. Look at the pencil through the side of the glass. Is the pencil still straight? Conclusion:
Light travels slower in water and glass than it does in air because water and glass are more dense than air. As light travels right from one medium into another, they are slowed and bent. This is called refraction. When you look at the pencil through the side of the glass, it appears to bend where it enters the water because the light rays are bending. Aim. Kids, even you can create your own rainbow. Let's see with this experiment.
Requirements:
Scissors, 3 by 5 inch index card, tape, tall drinking glass, water, 8 1/4 by 11 inch sheet of white paper.
Procedure:
Cut a 1 by 3 inch rectangle from the center of the 3 by 5 inch card. Tape the card lengthwise to the glass so the opening is directly over the rim. The rim of the glass should be in the center of the opening. Fill the glass to the rim with water and set it on a flat surface in front of a sunny window. Sunlight should shine through the glass via the hole in the card. Place a sheet of white paper on the floor in front of the glass. A rainbow will appear on the paper as the sunlight shines through the water.
Conclusion: a beam of light is actually made up of 7 colors that the brain perceives as one. Each color in the beam vibrates at a different speed. When sunlight passes through water, each of the colors in the light is slowed and bent to a different extent. This procedure, a colorful arc, is known as a rainbow. The colors that vibrate faster are bent more than those that vibrate slower. Violet vibrates the fastest, so it is found on the inside of the arch. Red vibrates the slowest, so it is the outermost color.
Aim. Sometimes the sky appears red at sunset. It is because of scattered light in the atmosphere. Our next experiment will tell us how it works.
Requirements: water, large glass jar or plastic container, golf ball size of piece of clay, flashlight, milk, spoon. Procedure: pour water into the container until it is about 3/4 full. Place one container on a flat surface. Press the clay onto the flat surface about 3 inches from the container. Press the flashlight down into the clay so that it stays in place and is pointed at the container. Pour milk into the water until the container is almost full. Stir with a spoon. Wait for the mixture to become still. Then shine the light through it. Observe the container from the side opposite the flashlight. Conclusion:
The light we see is made up of different colors that move at slightly different speeds. When the beam of light passes through the milk and water mixture, it strikes tiny particles that break the light up into different colors and scatter it. When you look at the container from the side, opposite the flashlight, you see light rays that have been scattered. Therefore, you see only the longer, slower, red light rays. A similar effect takes place when sunlight passes through the atmosphere. The sunlight hits particles in the atmosphere that break it up and scatter it. During the day, it is scattered a little and you see the sky as blue. At sunset, the sun is low on the horizon and must pass through more atmospheres. The light is scattered more. In fact, it is scattered so much that you don't see the faster rays, only the longer, slower red rays. Aim. Do kids enjoy playing in fog?
Yes.
So do you know what fog is?
No.
Fog is simply a ground-hugging cloud. Here's how to create your own fog in your bottle.
Requirements: empty 2-liter soda bottle with no cap, very warm water, large ice cube. Procedure: fill the bottle with very warm water to heat the air inside. Let it sit for a minute. Pour out all the water but only leave an inch of the water in the bottle. Place the ice cube over the neck of the bottle so that it completely covers the opening. Conclusion:
The warm air inside the bottle contains water vapor. The water vapor cools when ice is placed on top of the bottle. It condenses into tiny droplets which look much like fog. Aim. Do you enjoy playing in the sand?
Yes.
Sand does not retain water. Some types of soil hold water and some don't. Let's try this experiment in water retention to determine which types of soil are best for retaining water.
Requirements: pencil, 2 paper cups, 1 cup sandy oil, half cup clay soil, 2 measurement, 1 cup water. Procedure: with the pencil, make a hole in the bottom of each paper cup. Fill one paper cup with sandy oil and the other with clay soil. Hold the cup with clay soil over an empty measuring cup. Pour half cup water into the cup filled with clay soil. Measure how much water drains through in 2 minutes. Now hold the cup with sandy soil over another measuring cup. Pour half cup water into the cup filled with sandy soil. Measure how much water drains through in 2 minutes. Conclusion.
There are many different kinds of soil. Soil is formed from weathered rock and minerals. Its texture is influenced by the climate and plants in the area. Clay soil have a fine texture with few air spaces between the grains. It holds water well. Sandy soil has a coarse texture with many air spaces between the grains which allow water to drain through it easily. Aim. What are your hobbies, kids?
Collecting stamps.
Collecting rocks.
If you are a rock collector, this experiment is perfect for you. We shall determine the carbonate content in the rock.
Requirements: collection of rocks, water, metal nail file, eyedropper, white vinegar. Procedure: if you don't already have a collection, gather a few rocks from outside. Try to find a variety by looking in different areas. Rinse the rocks in plain water and dry them. Make a slightly rough patch on each rock by rubbing the surface with a metal nail file. With the eyedropper, place 1 drop of vinegar on the rough patch of each rock. Observe the reaction on each rock. Conclusion:
Certain rocks are made up of the remains of tiny shelled sea creatures called carbonates. When carbonates come in contact with a weak acid, such as vinegar, it creates a chemical reaction that produces carbon dioxide gas. If you see a little bubbling when you test a rock, then it probably contains carbonates. Other rocks should not have any reaction to the vinegar. Aim.
do you know that rocks wear away by water? Wearing away of rocks and soil by water is called erosion. In this experiment, we will test how plants affect the soil erosion. Requirements:
3 shallow baking pans, 2 cups pebbles, 2 cups soil, newspaper, 4 books, leaves, twigs and grass, 2 cups water, colander.
Procedure:
Fill 2 baking pans with pebbles, then cover the pebbles with soil. Place the third baking pan on a flat surface covered with a newspaper. Stack 2 books at each end of the pan. Lean the 2 soil-filled pans against the books so that they tilt downward into the third pan. In one of the soil-filled pans, cover the soil completely with a layer of leaves, twigs and grass. Pour 1 cup water through the colander into the pan with the leafy layer. Observe what happens. Pour 1 cup water through the colander into the pan with just soil and pebbles. What happens this time?
Conclusion:
Rainwater can quickly wash away unprotected soil because there is nothing to anchor it in place. Plants, grass, leaf and twigs keep soil from eroding by shielding it and anchoring it in place. Much of the soil from the pan, without the leafy layer, is likely to have washed into the spillover pan. Aim. Sound creates invisible sound waves. We will perform an experiment to see something that is unusually visible.
Requirements: coffee can, both ends removed, plastic wrap, large rubber band, 1 tablespoon sugar, small metal pan, and metal spoon. Procedure. Set the coffee can on a flat surface. Place a piece of plastic wrap over the top of the coffee can. Secure the plastic wrap with a rubber band. Sprinkle the sugar on top of the plastic wrap. Hold the metal pan within an inch of the side of the can. They should not be touching. With your free hand, bang hard on the side of the pan with the spoon. The sugar particles will jump. Conclusion.
When you bang on the pan with a spoon, you cause the nearby air molecules to vibrate. This vibration passes through other air molecules in waves called sound waves. When these waves of vibrations enter your ear, your brain interprets them as sound. In this experiment, you cannot see the waves, but they are what make the tiny grains of sugar bounce on the plastic wrap. In. We can transfer sound waves to our ears by the spoon. Let's see how.
Requirements: 2 feet of lightweight cotton string, metal spoon, table. Procedure. Tie the center of the string around the handle of the spoon. Wrap one end of the string around each index finger. Place the tips of your index fingers in your ears. Lean forward so that the spoon taps against a table. In your ears, it will sound like a bell ringing. Conclusion.
Sound is actually just waves of vibrations. When the vibrations reach your ear, your brain perceives the vibrations as sound. Sound vibrations travel more easily through solids than they do through air. Sound waves that reach your ear through a solid are stronger than those that are traveling through the air. By striking the metal spoon against the table, you start the vibration which travels directly up the string, a solid, and into your ears. In.
The ball comes down under the force of gravity. Let's find out if the force of gravity is stronger for bigger objects. Requirements: tennis ball, marble, crumpled ball of aluminium foil, baseball, 2-inch square block of wood. Procedure. Stand up straight and hold one of the 5 test objects listed above in each hand. Be sure to hold them at the same distance from the floor. Let go of the objects at exactly the same time and watch them drop. Do they hit the floor at the same time? You may want to ask a friend to observe from floor level. Repeat the experiment several times using a different pair of objects each time. Conclusion.
Earth's gravity causes objects to fall toward the center of the planet. The ground, however, stops the fall. The force of gravity on the objects you tested is equal, no matter how big or how heavy they are. Consequently, they fall at the same rate. In. Everybody has a center of gravity. By this demonstration, you will see how important it is.
Requirements: only one handkerchief. Procedure. Stand with your feet slightly apart in the middle of a room. Drop the handkerchief in front of your feet. Then bend over and pick it up. Now stand with your back against a wall. Drop the handkerchief in front of you. Then try to bend over and pick it up. What happens to your balance? Conclusion:
You have a center of gravity or an innate sense that helps you stay balanced even without having to think about it. As you move, your muscles are constantly making adjustments to keep you balanced. When you bend over, your body makes dozens of automatic adjustments, such as leaning back slightly or shifting your hips. When your back is against a wall, your body can't make these adjustments. You can't pick up the handkerchief this way without losing your balance. Aim. Let's see how we can perform a balancing act with the help of center of gravity.
Requirements: knife, potato, new pencil which is sharpened, empty 2-liter soda bottle with cap, 2 metal forks of equal size. Procedure: ask an adult to help you cut a 1-inch thick slice from the center of the potato. Push the pencil through the center. Place the cap bottle on a flat surface. Try to balance the pencil on its eraser on top of the cap. Will it work? Stick the 2 forks into opposite sides of the potato. Now try balancing the pencil on its eraser again on top of the soda bottle. You may have to adjust the forks slightly. Conclusion:
All things have a balance point or a center of gravity at which they are in perfect balance. The pencil with the potato is top heavy and will not balance. By adding forks to the potato, you change the center of gravity. With a little work, you can make it balance. Aim. This next experiment seems to defy gravity. It's just another example of how the center of gravity works.
Requirements: 2 plastic funnels, masking tape, 3 books, each 1 inch thick, 2 yardsticks. Procedure: hold the wide ends of the 2 funnels together. Secure them with masking tape. Stack 2 books on the floor. Place the 3rd book 30 inches in front of the stack. Place the end of each yardstick on opposite sides of the taller stack. Rest the other ends of the yardsticks side by side, with the ends touching on the single book. The yardsticks will form a V shape. Place the funnels at the bottom of the yardsticks so that the taped part of the funnels is at the center of the V. They will appear to roll uphill. Conclusion:
As the funnels begin to roll, they are actually slipping lower in the widening track. At the beginning of the track, where it is narrow, the center of the funnels is resting next to the yardsticks. As the track opens up, the funnels slip lower and lower until the ends are resting next to the yardsticks. The center of gravity of the funnels shifts downward, and the funnels appear to roll up the V track. Aim. Do you know what are tornadoes?
It is a storm.
Correct. Tornadoes are amongst the most destructive windstorms on Earth. Here we'll create a tornado in a bottle to demonstrate the funnel from such storms.
Requirements:
Marker: 2 empty 2-liter soda bottles with no caps, water, food coloring or glitter, duct tape.
Procedure:
Label the bottles number 1 and number 2. Fill bottle number 1 about 3/4 full with water and add a few drops of food coloring or some glitter. 2. You may need someone to help you with this step. Turn bottle number 2 upside down over bottle number 1. Secure the necks of the bottles together with duct tape. Turn the bottles over so that number 1 is on top. With a good grip on the joint bottlenecks, swirl the bottles in a circular motion. Set the bottles on a flat surface. A funnel of water should form as the water drains down into the bottom bottle.
Conclusion. A tornado is a very powerful whirling windstorm which usually starts when a warm air rises and cool air sinks, forming an area of unsettled air called a storm cell. Differences in wind speeds probably causes the air around the center of the storm cell to rotate. This creates a whirling funnel cloud. Once it hits the ground, it becomes a tornado. In this experiment, you move the bottles in a circular motion to get the water spinning. It forms a funnel of water similar to the funnel of wind in a tornado. Did you all enjoy learning super simple experiments?
Yes, Maya.
Maya, Vayu, we are very thankful to you for teaching us these experiments, as we carry them in our day-to-day life but were not aware of them.
Don't worry kids, we are here to help you. Any one of you has any more queries?
No, Maya.
No, Vayu. Bye, Maya. Bye, Vayu. Bye.
So, kids, enjoy your party and hope to meet you soon.
Bye.
Great is the world in which we live. It has so much to give, so much to give. There is so much to know while we grow. Lots of things to learn.